Hello and welcome to Math 252, Calculus 2 here at Cañada College. My name is Lapuz. In this video we will take a look at checkpoint 4.7, and here they're asking us to create a direction field for the differential equation y prime is equal to x squared minus y squared, and sketch a solution passing through the point -1, 2. So the idea behind a direction field essentially is a graph that takes in a point and then outputs a slope. So if we take a look at this equation, we can literally replace y prime with dy dx if we want to look at it as a slope. And what we're saying here is that we can create a table, and that for every xy point that we look at on the graph, we will get a slope for dy dx. So let's get to the actual point that they're giving us. The actual point that they're giving us is -1, 2. So let's start with that, -1, 2. And if we put that into this equation, x is equal to -1, we're going to square that, so that's going to be +1. And then minus 2 squared, which is 4, so this is going to give us a -3. So at the point -1, 2, at this point right here, we're going to have a slope of -3. So we generally try to draw a line segment. You can have an arrow or not, but just as a line segment, that would kind of represent the slope of -3. So it's fairly steep, going downward from left to right. Now, the idea is to do this for a whole bunch of points, like 0, 0. So let's do this more generally with a different color. 0, 0. 1, 0, 1, 1, -1, or let's put 0, 1, -1, 1, -1, 0, -1, -1, and 0, -1. Let's stop there because we just want to get a sampling, and actually in general this is not what we're going to do, because we're just going to rely on some technology to do this for us. 0, 0 will give us 0. If x is equal to 1 and y is equal to 0, we get 1. If they're both equal to 1, you'll have 1 minus 1, which is 0. This is -1. This is going to be 0. This is going to be +1. This is going to be 0. This is going to be -1. So we'll have slopes, a bunch of slopes of zeros and ones, and -1. So at the origin, we get a slope of 0. At the point 1, 0, we're going to have a slope of 1. At the point 1, 1, we'll have a slope of 0. This is the point 1, 1. At the point 0, 1, we'll have a slope of -1, so this is going to be going the other way. Oops, -1. I make that going this way. At the point -1, 1, we'll have a slope of 0 again. At the point -1, 0, we'll have a slope of 1. And we'll have a slope of 0. And one more here, I'll have a slope of -1. So it's kind of hard to visualize the big picture out of this, but that's the general idea. Now, to actually get the big picture, well, before we get to the big picture, what we're going to be interested in is finding a solution passing through this point. So passing through this point, we'll start off with a slope going steep, and then it looks like it might still be going negative. And then over here, eventually we'll have a slope of 0, and then it looks like it might go up. But I'm not exactly sure how this is going to look like until we plot more points, and plotting points can get a little tedious. So we're going to rely on a slope field generator that we can find online. If you just Google slope field generator, you can get that, and I will run this here in our video. This particular one is a GeoGebra slope generator. It's powered by GeoGebra. So let's see. Here's the slope generator that would come out. So we're going to put in an equation, and our equation is x squared minus y squared. And let's not put any solutions yet, and let's run it, and this is how it's going to look like. Now if we zoom in around those points that we were looking at 1, -1, 1, and this has, it's not quite 1, 1, but it looks like it's getting close to the slope of 0 somewhere over here. And then you kind of get the general idea. And so this is what the slope field is going to really look like. Now, to actually get our solution for this particular program, I can click on a solution. It says solution A, and I can take that point and I can click and drag that point to the actual point that we want. And so I think the point that we want is -1, +2, which is closer. It's something like that. Okay, that looks like it should be close enough. I think we went a little too far. All right, that's close. In any case, you can see this going down. We anticipated a negative, kind of a steep slope of -3. It goes down, and then passing the y-axis, it still kind of has a negative slope. At some point over here, your slope will be 0. So this is where you hit a minimum, and then it goes up, and then it starts to follow this along this line. All right, so that's going to be your vector field, your slope field, and the solution that passes through the point -1, 2. All right, that's it. I hope that helps.